Hello everyone, I'm Eliza, and in this video we are going to talk about steganography. This learning video aims to present and demonstrate a thorough comprehension and application of steganography. Here's an outline of what we're going to talk about today, and by the end of this video, I hope you will understand and learn more about steganography and be able to answer this set of questions about the topic. So first, we study the definition and uses of steganography. The word steganography is derived from the Greek word steganos, meaning hidden or covered, and the Greek root graphy, meaning to write, thus translating to covered writing or hidden writing. Steganography is a technique or method used to hide secret information through an ordinary file to hide suspicion from others. It aims to protect secret data within an audio, video, image, or text file from malicious attackers. In short, steganography has the power to conceal information in plain sight. It hides messages in such a way that no one, apart from the sender and the intended recipient, suspect the existence of the message. Steganography is used to conceal the existence of a message from a third party and to hide data inside almost any other type of digital content. According to Kessler, steganography works by hiding the covert message but not the fact that the two parties are communicating with each other. The steganography process generally involves placing a hidden message in some transport medium, called a carrier, to form the steganography medium. Next, we study the background and the history of steganography. This answers the questions: who invented steganography, where did it originate, and when did the use of it start? Steganography is not a new term or technique. It is already an ancient practice being used in various forms for thousands of years to keep communications private, and back then, steganography was mostly done physically. The first use of steganographic technique dates back around 440 BC in ancient Greece. For instance, people carved on the wood of wax tablet and then covered it with a fresh layer of wax to deliver secret messages successfully. In the same time period, the Greek ruler Hystaios also used steganography by tattooing the message on a slave's scalp and waiting for his hair to grow in order to disclose and send the secret message. In this way, the recipient can uncover the message through the slave's head and reply by doing the same technique. More modern forms of steganography were invented as it continued to develop over time. Next, we move on to the types of steganography. Steganography is divided in two types, namely physical and digital steganography. First is invisible ink. This type of steganography works under the principle that a message can be written without leaving any visible marks to avoid suspicion from others, and these messages are only revealed after a certain treatment is applied. Different varieties of substances are used as invisible inks, such as lemon juice, wine, and vinegar are revealed when heat is applied, while other invisible inks, such as laundry detergents and sunscreen, becomes visible when exposed to ultraviolet light. Starch and iodine, iron sulfate and sodium carbonate, and salt and silver nitrate are combinations that creates a chemical reaction which reveals hidden messages as well. This is one of the most common steganographic practices throughout history. However, it may not be the best technique to utilize if messages are being concealed because messages can be uncovered easily. Null ciphers are where secret messages are embedded by using variety of techniques hidden inside the normal text. This allows us to create a mundane text where every nth word or letter is a component of the hidden message. One can utilize null ciphers with any scheme he desires provided that the recipient knows the technique used in the text. However, null ciphers are not the most efficient when communicating secretly because producing and creating this type of steganography can be difficult and time-consuming. Here's a self-made example that I created to further illustrate the use of null ciphers in messages. For instance, if we use a null cipher to code something into the second letter of every word, we can take a message like, "Is he and Edward sharing several glossy apples?" And we can see how this sentence contains a secret message of "send help." Here's another self-made example that I created to further illustrate the use of null ciphers in messages. For instance, if we use a null cipher to code something into the first letter of every fifth word, we can take a message like, "I'm really an effervescent person to work with, so you should better start catching up quickly and be a vivacious, joyful, and enthusiastic person like me to successfully enjoy our time together." And we can see how this sentence contains a secret message of escape. Another early steganography scheme was Bacon cipher, invented by Francis Bacon. This works by hiding secret messages in the format of a text rather than its content. It allows us to write a seemingly normal text or innocent message by using a combination of different styles. Bacon cipher is really just a simple binary system, and it's not constricted to font types. By manipulating and changing the spacing and the size of a letter, or writing the message slightly above or below the lines, one can conceal a message with A and B system using this steganography type. The fourth one is microdots. It is one of the best techniques to use if you want to conceal information and make messages invisible. In 1925, Emanuel Goldberg created a method that shrinks down a regular printed page to 1/100 of a square millimeter. Microdots allows us to conceal great amount of information without leaving any obvious trace. Unless an adversary is already suspicious, microdots are almost impossible to detect due to their tiny nature. This was utilized throughout World War I, World War II, and Cold War. However, microdots are not utilized nowadays due to the advancement of digital communications and other techniques. Lastly, we have printer steganography. Since the 1980s, various printer manufacturers print out a series of almost unnoticeable yellow dots wherein each dot is only a tenth of a millimeter in size on every single page by programming their machines. Their program is coded to show the printer's serial number and its date and time. It is utilized to track down currency counterfeiters and to aid the authorities in finding out which machine the notes were printed when they seized it. However, it is still possible that the printer can leave other markings on a page which can be used to identify a person. Next, we move on to the digital types of steganography. First is text steganography, wherein we conceal secret information within text files by modifying the format of text, altering words within a text, and using random character pattern. Second is image steganography. This hides data by using images as a cover source since there are great amounts of bits existing in the digital representation of an image. Next, audio steganography works by embedding secret messages into an audio signal that changes the binary sequence of the audio file. Concealing information in digital sound is said to be a harder process when compared to others. Video steganography is a mixture of image steganography and audio steganography wherein secret data is hidden in a digital video format. It also allows us to conceal a vast amount of data in a series of images and sounds. Lastly, network steganography hides information within network control protocols utilized in data transmission, such as TCP, UDP, ICMP, etc. It is also employed in several covert channels found in OSI model. Now let's discuss the techniques used in steganography. In one of the most popular techniques known as the least significant bit steganography, a person can insert the hidden message in the least significant bits of a media file. When each pixel in an image file contains 3 bytes of data, LSB steganography modifies the last bit of each of those bytes to hide 1 bit of data. So when a person looks at the original and the modified images, he won't be able to distinguish the difference since changing the last bit of the pixel value doesn't make a visually noticeable change to the picture. In palette-based technique, the attackers encrypt the message first and then hide it in a palette of the cover image. This utilizes digital images as malware carriers and transport a limited amount of data. This is also a method in which the malware is encrypted and takes a lot of time to decrypt. Secure cover selection is a complex technique wherein the blocks of the carrier image are compared to the blocks of their specific malware first, and then a candidate will be chosen to bring the malware if an image with the same blocks as the malware is identified already. As said earlier, least significant bit substitution is the most common steganography technique, using mostly image and sound carrier files. As the name suggests, LSBS involves overwriting the bit with the lowest arithmetic value. The outcome of this process changes the original output very slightly. This is done slightly enough to be unlikely detected by human senses. Let us discuss the example made by Douglas, Bailey, Leaney, and Curran from their journal article in 2018. In this example, they take the 3 neighboring pixels, as seen in the first photo. Then the binary representation 11001000 is inserted into the least significant bits of this section of the image. Finally, the resulting grid looks like the second photo. You can see that the binary number was embedded into the first 8 bytes of the grid, but only 3 existing bits, or the bits denoted with underline, had to be changed for the required data to be embedded. Altering the LSB of a pixel results in minimal changes in the intensity of the colors. If these modified images are not identified by others, then the data hiding the information is successful. Lastly, we will distinguish the differences between steganography and cryptography. We can refer to this table in order to distinguish where steganography and cryptography differ. Both of them have almost the same goal, which is to protect a message or information from third parties. However, they use a different way to protect information. Steganography is different from cryptography. It does not alter the format of information, but it hides the existence of a message. And once the presence of a secret message is discovered, anyone can use the secret data. On the other hand, cryptography alters the information to ciphertext which cannot be understood without the decryption key. If you possess a decryption key, then you can figure out original message from ciphertext. You may also refer to the set of resources that I use for this presentation to know more about the topic. That's all for this video. I hope you understood and learned more about steganography. Thank you for listening.